I'm David Langton. I'm VP of Product at Matillion, and I'll be joined virtually, at least, by our head of R&D, Jamie Cole, for a quick technology demo of Matillion and Amazon Redshift later on. So, what we're going to do is talk about improving analytics productivity for overwhelmed data teams. I'm going to go at quite a pace. We're going to do a quick tour of the core challenges facing our data teams today. Look at how we got here. We'll take a look at 3 potential solutions, although a little spoiler alert, one of those solutions isn't really a solution at all. And in the middle of all of that, we'll also do a quick technology demo of Matillion ETL in action, and then wrap up with some final suggestions. So since productivity is the subject, let's get moving. Okay, so really, what are the challenges that our teams face today? Well, there are a lot. Some of them are cultural, some of them are technological, and so on. But in terms of data right now, 3 really big problems are the volume of data being produced, the variety of data being produced, and typically done in a siloed environment as well, and the velocity required to do something actionable with that data before its value is completely eroded. So they're the 3 V's. They're really the challenges. And so just on volume, an eye-watering statistic is that Matillion's own customers shift around 5.5 trillion rows of data every month. And that's just ingestion. That's not things they do with those rows. That's not rows being output anywhere. And so really, it's an explosive growth. And that's not just because we're acquiring more customers all the time, although we are. The actual amount of rows processed per customer is ever increasing as well. And there's a little statistic there, 63% increase in data volumes, but just double check that. That's monthly increase in data volumes. So data volumes massive. Another little stat there, 45 zettabytes will become 175 zettabytes by 2025. Well, maybe not all of that data is suitable for data warehousing and analytics, but the growth pattern will be mirrored in analytics. So volume, a big problem. So if we just turn for a second about variety, well, over 1,000 data sources are required for an enterprise these days. So when all data was in flat files, that wasn't, we didn't just have this range. We've got terrific variety. A new SaaS business is launched, all of the time. And every time a new SaaS business launches, it's a new silo of data. So data warehousing, just as relevant today to try and get a single view of a customer, a single view of a supplier or whatever, it's going to be way more semi-structured and unstructured data too, because of the pace everybody is moving at. Normalizing a data model takes time, then it's harder to change. But a semi-structured model which matches the object structures in the application, much faster to work with, at least initially. Also, while we're talking about velocity, well, let's just move on and think about how fast you have to turn data into an action for it to still be relevant. Now, I picked a really extreme example here. By the time you wake up, grab a newspaper, digest the business pages, and then get on the phone to your broker, well, a bot will have turned that news feed into an automated trade in milliseconds. And I'm not saying whether that's a good thing or a bad thing, by the way, but it's definitely a fact of modern trading. What it underscores is the fact that data has value, which erodes the older it is. And so it's all about getting insights quickly. So let's just, after those 3 V's, let's just take a quick look at how we got here along the data analytics timeline. And actually, I just mentioned that all data used to be in flat files, but very quickly, database files got structured. And if anyone remembers DBM files and lots of variations on DBM files, they then needed management. So DBM files became database management systems. Then the relational model made that a relational database management system. And by the 1980s, SQL appeared and quickly became a de facto standard that we still use today. Although I'm slightly uncomfortable using the terms SQL and standard in the same sentence, that is apparently what it is. But of course, all of these systems are really online systems and data stores that power business applications. If you want quality reporting from these systems, there are a whole number of issues with that. Firstly, the data needed by a single report may come from multiple systems. So it's just a non-starter to take it and expect one system to be able to do that. But even when that's not the case, data volumes are the enemy of the relational database management system. These systems are heavily optimized to drive single row workflows with ACID properties, not to service bulk analytics queries. And so actually the data warehouse came along, which in the early days was more of a set of patterns for designing schemas so that a relational database system could actually do a decent job of analytics. And so a few iterations around star schemas were often implemented on heavily indexed relational database systems, but they didn't really keep pace, and they had real difficulty with machine-generated semi-structured data. And so for that semi-structured data, Hadoop emerged as the way to do analytics at scale. And I say at scale, not in the cloud, although these days, of course, it is. But this goes back before the cloud as a way of doing scalable data processing on semi-structured data. Now, the real alternative now to relational databases or Hadoop is an analytical database of some sort. This is not a new concept in the cloud. People were building analytics appliances systems on premises for a long time and squeezing all the possible power from those systems that they ran on. But in the cloud, an analytical database that can handle semi-structured and structured data has kind of become the norm over the last few years. And so that Hadoop ecosystem grew and twisted and gave us the data lake. And technology like Amazon Redshift Spectrum is now increasingly blurring that line between data warehouse or analytical database and data lake, giving us kind of a new term to get used to, the lake house. Now, if we look at some of the technology players here, and we mentioned Hadoop earlier, that's been around for quite some time, well, things are definitely hotting up. So many new technology entrants and players, so many moving at pace, and so many companies that are brand new, giving us net new technology and moving to the point of record-breaking IPOs within just a few years. This all hints to the acceleration in this data space. I think it also shows a few signals towards convergence of cloud data warehouse and data lake again, with a great example, Amazon Redshift Spectrum. And so with all this explosion of data and the 3 Vs, which isn't going to let up, by the way, you can expect that to continue, what should you then expect? Well, here's 3 basic options to deal with the 3 Vs. And I kind of hinted a little bit that one of them might not be the best thing to do. Option 1, failing to do the work, is probably not a winning strategy, but the other 2 will give you some mileage. So let's take a look at each of them in turn. Failing to do the work, well, maybe not a great option, actually. Now, you can analyze all of your data, or where that's not feasible, you can take great care to use random sampling so that you can draw valid statistical inferences from that sample. But analyzing the data you happen to have to hand, the available data, that's likely to introduce bias, lead to poor decision making, and ultimately defeat the purpose of trying to be data driven in the first place. So you either need good, clean data or a carefully constructed sample, but anything in between might actually end up being your enemy. And in fact, Thomas Cook, very sadly, after a long tenure and a very successful business, unfortunately failed quite recently. And I'm sure there are many and varied reasons, but they were known to be behind the curve in digital transformation. Eventually, they ended up declaring bankruptcy and stranded passengers all over the world. So when you fail, it has real world consequences, even when it's data related. Having said all of that about this is not a valid option, doing nothing, you can and should still think about scope. I said a minute ago you need the data or a sample, but there is a valid way of moving forward by just defining a slice. So if you take a single subject area or business unit, and it won't solve all the problems, but it will demonstrate the art of the possible for that single business challenge or single department. I guess what I'm saying here is start small, iterate quickly, deliver quick wins, etc. Not rocket science. This is the sort of thing actually that's top of mind for developers and code-heavy projects. And you really should think about the same things for data projects, regardless of how much coding might actually be involved. And so with that said, let's actually go and maybe look at something that might be more useful, expand the pool of contributors. And I'm not basically boiling this down to hire more techies. That's not what I mean. Just to be clear, you can do that, but that's not what I'm saying. Growing the data team can mean thinking about all of the myriad of skills required to get the job done, the job of doing data analytics in the cloud. Well, one thing is to select tools from options that require less background knowledge of the technical configuration, which more require the team member to really understand the data and the need and the outcome that they're hoping to get from it. If from that starting point no programming skills are required, the number of people who can then self-serve and contribute will increase without additional headcount. An example of that might be a tool like Matillion Data Loader. This can reach out, it can grab data from relational databases or cloud services, CRM systems or marketing systems or social media platforms. It can go and get all of those different silos of data and load them into a single data warehouse platform like Amazon Redshift. It's fully software as a service, so there's no coding really required. It's point and click setup. So if you already have access to the data warehouse and the source data, you shouldn't really expect to need much more support. So do you really need a programmer? Does that need to go from one team to another and back again? Well, quite possibly not, in the simplest of cases at least. Now, if you think about slightly more full-on tools that do require a little bit more technical depth, well, it's still possible to expand your pool of contributors with some upskilling. Now, I remember training courses years ago where you went away for 3 days so packed with valuable material and the evening so packed with valuable alcohol that by the end of the week, you maybe retain 10% of that. It's not necessarily the best way to learn, and you don't need to do that anymore. There are other options available. There's a screenshot now on this slide from the Matillion Academy where we've taken a full Matillion ETL learning series on building a data warehouse and split it up into 15 and 30-minute achievable sections that you can do when you're ready. So upskilling is definitely possible and shouldn't be something that you have to take days and days out of your life to do. While I'm cheerfully suggesting, by the way, that you can have half of your organisation being data-led and self-service, I should probably just signal a quick warning. This isn't a new concept. The mythical person month, I've degendered it from the original book, you'll notice. This demonstrates the limitations of adding team members around a single deliverable. That all-important number of communication channels quickly swallows up available time, and you probably want a little bit of time left for actually doing the data analytics tasks. So tools that allow for collaboration as part of the offering without requiring extra cycles to coordinate work with others, they help a lot in this area. Okay, so I've talked a little bit about that. We'll move on now to thinking about improving the efficiency. This is getting more stuff done with the same amount of time sunk into it, aside from upskilling people, the other kinds of things we can do. And so we'll talk a little bit about, well, really thinking like an engineer, not necessarily as a programmer, thinking about reusability, automatic documentation, easy to read logic. And for data projects, we need to think about how that same carefully acquired, cleaned and sanitized data can be used and leveraged by analysts and data scientists via this lakehouse paradigm. And finally, I mean, in terms of collaboration, a problem shared is a problem halved. And in my case, a problem shared is often a job that gets done for me. So making it really easy to reach out and ask for help with a collaborator, definitely something that will massively boost productivity. And so if you think about the effort involved, not in doing a one-off piece of data analysis, if that analysis is useful, it's going to want to be refreshed. It's going to want to be furthered. More work will be done there. So if you build it as a repeatable pipeline that you can just rerun in the future from the ground up, well, that's really helpful to your future self. And most tools should encourage and make that available. So when starting to code something brand new, a developer will reach out and look for suitable libraries that they can import and reuse within their own projects. Data tools should offer that same functionality and support that same mental model. I'm about to build a date dimension. Am I the first person in the world to do that? No. So why am I starting from zero? There's got to be something out there to give me a leg up and to help. So you should choose tools that allow for reusing job logic and flows wherever possible. So just a quick picture here. We've got a Matillion ETL orchestration job, but actually the only component in it is this reusable job that we never shipped with Matillion ETL that does some schema detection. It's going to reach out to cloud storage, analyze a bunch of data, and with no prior knowledge, it'll determine the repeating structure found within the data values. I wouldn't want to have to start that from scratch. Very pleased that somebody got there first and did it, and I can just reuse their logic instead of having to create it myself from scratch. And the other thing, of course, is it's great to share within an organization, but that same reusable logic you should be able to find out on the internet, not just within your own organization. So community sites that support this do exist. Extending the functionality of the tool via contributed extensions is a massive time saver. Here we're looking at the Matillion Exchange and the Atlassian marketplace. You kind of get the idea. In fact, our customer Slack, they used repeatable patterns to reduce the number of discrete data ingestion workflows from 10 per data source down to just 1. And that allowed them as well to generate new reports in 30 minutes when they were previously taking 6 hours. So these aren't like 5% wins. These are massive game changers. Okay, I'm just going to distract us slightly with a demo. So I'm going to hand over to Jamie Cole, our head of R&D, who's going to do the driving, and I'll talk a little bit about what he's doing along the way. Okay, so just bear with me. Jamie, do take it away, please. What we've done here is deliberately started with a completely blank canvas. And so I wanted to see how far we could get in 7 or 8 minutes from a standing start. And so this is a fresh install, and we're just creating our first project. So we've done nothing yet. We need a name and a description. But what's key to a Matillion project is this concept of an environment. We're going to point at the AWS environment, in this case, with the IAM role attached to the instance. We could also use a set of access keys, although that's not as useful in terms of security. IAM roles are probably better. Since we've now configured the IAM role, though, we can go and look out in the account where we are running and discover Redshift clusters. So instead of having to cut and paste endpoints and usernames and remember passwords, actually we can just leverage the API to just auto-generate and pull this stuff in. So all we really need is to add a password, which we do not get from the API, and move on. Thanks, Jamie. And actually, there's just a few other niceties in an environment where we configure some defaults. You'll often use the same schema within the database. You'll often use the same bucket for staging data. And so it just makes a lot of sense to make this something that you can use defaults. So we now have a connection to our cloud. We have a connection to our data warehouse. And so now we can get on with the job of actually loading some data and doing something with it. The use case today is some product data. We're going to create an orchestration job to handle the extract and the load of this product data set. The job gives us a nice graphical canvas here. And the job really is we need to create a table and load some data into it. So nice and simple, except I don't know anything about this data. I don't know if it has a header row or not. I don't know what the data types are. I don't know how many records there are. I'm kind of flying a little bit blind, but that's okay. Rather than start with a create table or an S3 load, we can just use a tool to help us generate this and walk us through it. And so this is going to create that table for us and do the load, but it's going to walk us through it in a few steps so we can really get in touch with the data at each stage. What we need to do then is point this environment. We've already got the access key, so we can hop onto S3. We can grab a sample of the file that we want to load. This could be the full volume data. This could be gigabytes and gigabytes, but it doesn't have to be. It can also just be a sample. Again, you don't need to know how an S3 URL is constructed because we're just going to generate that for you as you click and navigate through. And now we're seeing the data for the first time. And it does have a header, and I can see that the commas are delimited, and that looks like a date. So this is already feeling quite achievable. And actually, if we go to the next step in the wizard, Matillion has automatically determined the table schema by extracting the column names from the first row. It's had a good guess at the types. It's found the maximum lengths of each value and put those into the size. And I think we even pad those a little bit because we expect the full data might just go a bit longer. So it looks basically like everything worked on first guess. So we'll just get on with running that. Now, it's generated my create table, which is great. It's generated an S3 load, which is apparently not great, actually. That's got a red border around it. What's happened here is the create table is perfectly valid. The S3 load has an error that the table doesn't exist. We've not ran anything yet. Nothing has been created. And so this is showing us that is an actual invalid state for this job. The table should exist by the time that runs. Well, if we just run the job, that create table will have just created it in time for the load to work. So the easiest way to get past this is just to run the job, at which point our table will get created or recreated, or will error if it already exists, depending on our settings. And that S3 load will generate a copy command and have Redshift ingest the data, which is a few thousand records. Excellent. So that was fairly painless compared to having to get a local copy of the file and create the schema manually. What I said at the beginning, though, is this is just the extract and the load. An orchestration can also do much more than load data from S3. We also have adapters and data connectors for CRM systems and marketing systems and generic APIs. You can see some there being scrolled through. They will also provide a wizard-based approach to selecting the available columns from the choices and the available data sources. So you should never really have to know in any detail what those things are in advance. It should pretty much guide you through it. So lots of help there to ingest the data. But when it comes to the transform, we're going to use a different job type for that because transforms, they're more like a definition that all get boiled down to some big chunky SQL statements that have the data warehouse, in this case Amazon Redshift, they have that data warehouse do all of the work, and that's why we need to separate those two job types. So we're going to read the data in, we're going to filter it a little bit just so that we can demonstrate how these jobs work, and I'm going to write the data out to a new table. Obviously in the real world these jobs are a little bit more complicated. We can explore the environment. We created a default schema called reinvent, and the only table in there is the one we just loaded. So we can drag that onto this palette or this canvas. It will automatically use a create table input. It will automatically configure the columns. We can, of course, edit that. If we don't need all the columns, we don't have to take them through. But the most important thing we can do now in a transform is to start to sample the data. We can see it for the first time in table form, and clearly that load generator did the right thing. They look like dates and numbers, and all the right things seem to be happening. So relatively pleased that this is working. But what we do want to do is filter the records, because I don't want them all. I actually just want the records where language is equal to EN. So again, no coding required. We can just add a filter component, build up the filter condition is equal to, obviously loads of other options around filtering besides that one, of course. And we've not run the job. We've not finished the job yet. We've not output the data anywhere. But if we want to know if that worked, just sample it again. Let's see if it worked. Well, it's less rows, so some records have been filtered out, so it's all looking promising. All the ones on the screen seem to be yeah, looks great. So that's, not only do we know that our job is working and we've done the right thing, we know all of that without ever having to run it or even finish it. However, I guess for completeness, we probably should finish the job off, so we might want to write that data out. And at these volumes, it's really not that important whether we write it out to a view. We could write the data back to S3 and put an external table over it so that it can be used in other tools. But if we're just being lazy and a little bit quick, we can just rewrite the table, which says drop it if it already exists, create it with whatever schema is required to hold the input data, so it'll just determine all of that automatically, and then bulk insert the data into it. And so when we run this job, very quickly we'll have a filtered view of that input table in an output table. And there we go. So nice and simple. Obviously it's a fairly simple example, but the point is that didn't really require a lot of head scratching or prior knowledge of the data to get somewhere and to do something useful with it. So I hope you found that useful. Now, if we just go beyond the demo, I'm just going to call out a few more things around efficiency. And I know that it's quite easy to write an SQL statement, so don't call me out on this. It can be quite quick to write SQL by hand, but think of your future self. If you think and come back to it a month later or a year later, or pass it on to another team member, they've got to read it to understand it, and that's slightly harder than writing it in the first place. And so in the real world, where many tables are required to produce a single result, the SQL quickly gets really complicated. But the diagram is always pretty readable at a high level, and then you can just lead in for the details as you go along. Here's an example of an orchestration job where, you know, I've no idea what's going on. I didn't write this job, but within a few seconds, I'm going to say that we're going to run a data transformation or report a problem, depending on whether a particular table's metadata looks how we'd expect. And I don't know what the metadata should look like, and I don't know why it's even important, but just by looking at the overall flow of this job, I know overall where we're trying to get to, and I know the right questions to start asking. Okay, so a little bit more on efficiency as well. In a lakehouse style architecture, well, data is considered by the data lake and data science teams and the data analysts and the data warehousing teams often quite separately. Now, they reuse the raw data, but they end up repeating a lot of things along the way, which just makes extra work. Acquiring, cleaning and validating business data isn't cheap and quick, so you want to make the most use of that and use it consistently around the business. So whereas this diagram shows a split where one community of users splinter off to do some data science, it begs the question why their needs aren't already being served by a central data team. So a better diagram might be this one, where in this case, you load once, you apply transformations once, you clean up the data once, and then you make sure everybody can leverage that nice, clean data, whether they're doing modeling or reporting or any other activity. Okay, so what we're going to look at here is just the emergence of some of the teams. So you're going to have data engineers looking across the layers of the system to ensure business users will get what they need. But it's really the analysts and the business users who can prepare and provide the transformation rules on the data they require. So those tools can run on an SQL engine. It all works great. And the analysts can continue to use SQL via their tools. And the data scientists can do their thing with their own tools, but share the same data set. That's essentially what we want to do. And so a concrete implementation of that might be Matillion at the top, Redshift plus Redshift Spectrum plus S3 in the middle, so that we've got some data sat inside of Redshift and some data sat in S3. But that's fine, that's okay, that all works. So there's an example of one concrete implementation. And then I'm not going to dwell on the subject of unleashing the cloud, because you're probably in the wrong room if you're not already trying to do that. But the idea here is, well, ETL can be done with a bunch of scalable nodes. The data warehouse can run as a bunch of scalable nodes, and the analytics can also run as a bunch of scalable nodes. That's so much easier in the cloud to get all of those different compute nodes up and down and scaling. But if you're prepared to use an ELT, that's an extract, load, then transform approach, rather than an extract, load, transform, then actually the ELT should be making the cloud data warehouse or the analytics stack scale. It shouldn't need to scale independently on its own. It already has that horsepower available. And here's just a couple of examples where moving to the cloud and using Matillion was a massive time saver for DocuSign and for Giants. This is really total time to get ETLs run. And then a final word on collaboration, because it can mean two very different things. Collaboration might mean working individually, but in a way that your work can be combined with others later on. For example, version control. It could just as easily mean collaborating in real time in a shared workspace across the internet. And so there's a couple of screenshots there where Matillion offers both of those styles to help you collaborate as much as possible. And so that was quite a fast pace for me anyway. So to conclude and just to wrap up, more data is coming. You will face the challenges of the 3 Vs. There are rewards, but it isn't without some risk. Of the 3 ways of coping, efficiency and expanding the pool of contributors will definitely help, and there's lots of ways to do that. And please look for tools that support reusability and collaboration to truly leverage the data team's potential for productivity. That's it from me today. Thank you very much for listening.